Hello students! Today we are going to talk about the periodic table again, which is because it's so awesome. And we're going to look at the groups and families in the periodic table as a review. So here we have the periodic table. And remember, this was developed by Dmitri Mendeleev. It classifies all elements in the universe. And right now there are 118 elements that have been classified in periodic table. And it's called periodic table because it's arranged in rows that are called periods. So the rows go across, right to left, horizontal rows. And each row indicates the energy level of the atom. So the first row has only one energy level. That first row includes hydrogen and helium. So hydrogen and helium are in the first row. They have one energy level. That's it. Second row has two energy levels. That includes lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Two energy levels, period 2. Third period is sodium, magnesium, and so forth. Has 3 energy levels. Fourth period is potassium, calcium, so forth. Has 4 energy levels. So this is the first period, second period, third period, fourth period. The fifth period has 5 energy levels. Sixth period has 6 energy levels, and the seventh period has 7 energy levels. So as they increase their energy levels, the size of the atom really increases. So you can think of it the size. Those atoms are getting bigger. And if you relate it to class, this might help you remember the difference between periods and groups. So in a classroom, a lot of times the seats are set up in rows. So you're in rows in a class. So the class periods, so periods are rows. And as you go through the periods, classes tend to have more and more energy. So by the time you get to the last period, class has a lot of energy. Although you only have 6 periods, atoms actually have 7. By the time they get to the 7th period, they have got loads of energy. They have more energy levels. So this is very similar. Think of it as a classroom energy in a class. Next thing is groups. Groups are the columns. Groups. They're also called families, but we're gonna just use the word groups for this. And they are indicated in Roman numerals. So groups then are up and down. Group 1, 2, 3, 4, all the way up to 18. So there are 18 total groups. And when we look at the groups, when they're placed in groups, there are certain properties that they share, that they have in common. Some of the groups, we can actually tell the number of valence electrons the atoms have by their group number. Not always though, so there's a lot of rule breakers in this case. But group 1, 2, 13 through 18, we can use those numbers to indicate how many valence electrons they have. Now remember, valence electrons are the electrons on the outside, the outermost electrons. So it's the number of electrons that are on the very outside energy level in the atom. And those electrons then are going to be the ones where the action is going to happen. This is where reactions will happen. So when 2 atoms come crashing together, say we have 2 atoms come together. Now in this case, we're not talking about nuclear fusion. So when I was talking about nuclear fusion, like what's happened in the sun, they're actually coming together and forming a new atom. If there's enough heat, like billions of degrees Celsius, nuclear fusion can happen. But if it's not hot enough, these atoms can interact with their electrons, because remember the electrons are on the outside of the atom. So when two atoms come close to each other, they can form what's called a chemical bond. So like oxygen that we breathe is not just one oxygen atom floating around. It's actually O2. So it's actually two atoms of oxygen. And they're chemically bonded together through their valence electrons. Their outermost electrons are the ones that are going to have the action. Okay, so if we look at group 1, which includes hydrogen, lithium, this column, this is a groups. Remember, groups are up and down. Group, up and down. Group, 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 group. Got a group dance, and period dance. Periods, this is periods. Groups. Okay, so here we have group 1. They all have one valence electron. So there's one electron on the outside energy level. Group 2 has two valence electrons. Groups 3 through 12 are like rule breakers. So they are transition metals. So we cannot look at those numbers and say it has that number of valence electrons because their valence electron numbers vary. They're in like transition. That's why they're called transition metals, because they can switch depending on what other atoms they bond with. Okay? So right now we're not gonna talk about 3 through 12 yet. When we go to group 13, we're continuing the numbering system though. So this is group 1, this is group 2, this is group 13 because we skipped 3 through 12. But 13 has a valence of 3. So it has three electrons in its outer energy level. So it's a valence number of 3. So it was 1 over here, 2, 3, 4, 5, 6, 7, 8. So this group right here these are the noble gases. And the noble gases, they used to be called inert gases because they don't really react. They're very non-reactive. Unless you apply electricity through the gas and then it glows. So it's like neon lights. So all of these really glow, but they glow different colors. This is when electric current is applied in the gas. But they all have 8 valence electrons. That's why they're so stable. All right. This is getting a little more advanced into like high school chemistry, but there's a rule that atoms tend to follow. It's Octet Rule. Octet, 8. In nature, generally, we go towards stability. So atoms want to be stable, and they want their energy levels filled up with electrons. They're more stable that way. So the Octet Rule states that atom is a synopsis of periods and groups in a periodic table. Woo!